surface, they can burst with the force of a gunshot. And when millions of bubbles explode simultaneously, the energy can send plumes of ash into the stratosphere. But before they pop, they act like bubbles of CO2 in a shaken soda. Their presence lowers the magma's density and increases the buoyant force pushing upward through the crust. Many geologists believe this process was behind the Paracotin eruption in Mexico. There are two known natural causes for these
Waar was die met vulkaan in Mexico? Nou, ik ga ze liever niet zien, elkaar zo.
Bubbles. Sometimes, new magma from deeper underground brings additional gassy compounds into the mix. But bubbles can also form when magma begins to cool. In its molten state, magma is a mixture of dissolved gases and melted minerals. As the molten rock hardens, some of those minerals solidify into crystals. This process doesn't incorporate many of the dissolved gases, resulting in a higher concentration of the compounds that form explosive bubbles. Not all eruptions are due to rising magmastatic pressure. Sometimes the weight of the rock above can become dangerously low. Landslides can remove massive quantities of rock from atop a magma chamber, dropping the lithostatic pressure and instantly triggering an eruption. This process is known as unloading, and it's been responsible for numerous eruptions, including the sudden explosion of Mount St. Helens in 1980. But unloading can also happen over longer periods of time due to erosion or melting glaciers. In fact, many geologists are worried that glacial melt caused by climate change could increase volcanic activity. Finally, eruptions can occur when the rock layer is no longer strong enough to hold back the magma below. Acidic gases and heat escaping from magma can corrode rock through a process called hydrothermal alteration, gradually turning hard stone into soft clay. The rock layer could also be weakened by tectonic activity. Earthquakes can create fissures, allowing magma to escape to the surface, and the Earth's crust can be stretched thin as continental plates shift away from each other. Unfortunately, knowing what causes eruptions doesn't make them easy to predict. While scientists can roughly determine the strength and weight of the Earth's crust, the depth and heat of magma chambers makes measuring changes in magmastatic pressure very difficult. But volcanologists are constantly exploring new technology to conquer this rocky terrain. Advances in thermal imaging have allowed scientists to detect subterranean hotspots. Spectrometers can analyze gases escaping magma, and lasers can precisely track the impact of rising magma on a volcano's shape. Hopefully, these tools will help us better understand these volatile vents and their explosive eruptions. Did you know that there's an even more explosive and destructive kind of volcano known as a supervolcano? 650,000 years ago, when the Yellowstone supervolcano last exploded, it covered North America in nearly 2 meters of ash and rock. Find out more about these epic eruptions with this video.
Die is al wel een keer uitgebarst, joh. Dus krijg je dan de chauffeur net deelt van Walmart. Kan dus op de deur zien welke chauffeur het was en dan had hij 3 million save miles. Dus die man heeft gewoon 5 miljoen kilometers van de weg gereden. Dat is wel. Dat is toch wel een beetje een oude vent inderdaad.
Ja.
Moet wel een beetje op leeftijd zijn weer.
Heb je zo gereden? Volcanism behind the arc is widespread and lacks a prominent subduction signature, suggesting slow
Weer wat druppeltjes in doen.
To the gravel and pebbles along a river. Earth's solid exterior. From towering mountains to the gravel and pebbles along a river. Earth's solid exterior is made of a huge variety of rocks. Some are even being formed this very moment as active volcanoes spew lava that hardens as it hits the atmosphere of ocean. But most of the Earth's rocks are extremely old. Each rock is a shapeshifter, shifting form over time with a history that can span millions of years. And here's what geologists and rock climbers and your aunt with a collection of heart-shaped rocks know that lots of us overlook. One rock is not just like any other. I'm Alize Carrere, and this is Crash Course Geography.